Hello everyone, my name is Neha Kartam and this is the fourth lecture on Introduction to Microcontrollers. In this lecture, we're going to learn about assembly language statements, what are the different elements which are used in it. So let's get started. First, let's know about what is assembly language. So assembly language programming is a low-level programming language which is designed for a specific type of a processors. And assembly language, it uses a method of writing programs using instructions that are symbolic equivalent of a machine code. And the syntax of each instruction is basically structured in such a way so that the assembly code can be converted into a machine code using a assembler. Now here you see two subtopics. First is the components of assembler program, and under that we have assembler directives, we have assembly language instructions, we have comments, and then we have another subtopic which is elements of an assembly language statement, and under that we have label, mnemonics, operands, and comments. So I'll just quickly go through this, and then we're going to discuss assembly directives in detail in the next lecture. So let's first understand what is assembly directives. So these assembly directives, these are the assembler commands that are used to control the assembler. For example, the input, or if you want to allocate the data. So for that, this assembler directives are used. And an assembly program, it should be terminated with an end directive. So every time you use this the assembler directives, which we are going to see in the next lecture, then you will have to terminate the program with end directive. So any statement after the end directive will be ignored by the assembler. Now next is your assembly language instructions. So these are the instructions which are used by PIC 16 or PIC 18 instructions. They all incorporate assembly language instructions, and some are defined with labels. If we talk about PIC 18 a microcontroller, then in that one it uses around 77 different instruction sets. So we will learn about the instruction sets in later coming lectures. And then we have comments. Comments are two types of comments which are used in the assembly programming. The first type is used to explain the function of any single instruction set or a directive, and the second type basically explains the function of a group of instructions or directives or whole routine or whole program which you basically make. Now next we have our elements of an assembly language statement, and under that we have label, mnemonics, operands, comment. So we're gonna see each of them. So let's start with the second slide. So as I told you before that we're going to cover this in the next lecture, so this is just indicates that this is going to be covered in the next lecture. Now we have label field. So the label field, it must start from the first column. So I'll directly go to this example. So you see here, this weight and underscore again is basically your label. So this is your first column, this is your second column, this is your third column. Okay, so the label should always start in the first column. So whatever you have here is your label, and so it is followed by a tab, a space, or a colon like this. So if you have something like this, or the end of a line, then that will be your label, and it must start with a alphabetical character or underscore. So you see this is an underscore, and this is the and followed by the alphabetical character, and this directly starts with the alphabetical character. And it may contain numeric characters, underscores, and question marks. and it may contain up to 32 characters and is case sensitive by default. So when you use the label, then the same characters, the way you represent in your label, you will be using in throughout your program. You cannot change that. So for example, if you're using the small letter weight, then this should be represented the same way throughout the program. You cannot make it W as uh, capital letter, and if you do make, then you will have to make the change from the beginning. So I hope you understand, like you have to make the label in such a way, and in such a way that all the characters should be same type, either uppercase or lowercase, and you'll be using that throughout the program. So this is, in this particular example, this weight and underscore again is your label. Now let's move on to the next, which is the mnemonic fields. So this field can either be an assembly instruction mnemonic or an assembly directive, and it must be in the second column. You can see this is our mnemonic field, and if there is a label on the same line, then instruction must be separated from that label by a colon, or by one or more spaces, or you can use like tab to make it like separated from the label. So for example, here loop and false is our label, okay, and the second column which says add lw incf equ. So these are all your mnemonic fields. So let's read here. Can be an assembly instruction, mnemonic or assembly directives, must begin in column 2 or greater, must be separated from the label by a colon or one or more spaces or tabs. Now let's move on to the next slide. So next we have is the operand field. So the operand field is it basically follows the instruction mnemonic. So you know that this is our label, this is our mnemonic field, and whatever you see after this is your operand field. This is your operand, and this operand provides instruction or arguments for an assembly directives, and it must be separated from the mnemonic field to make it more clear, like what is label and what is mnemonic, and what is your operand field. Let's read here. Must be separated from mnemonic field by one or more spaces or tabs. Multiple operands are separated by commas. So this is your operand. So far we learned the label, mnemonic, and operand fields. We will learn about this, what all these represent and what these mnemonic field represent later in the slides, later in the next lectures. Now next we have is the comment field. So this comment field is totally optional. It depends on you if you want to write it or not, but it is advisable to write it just in case if you want to refer to your code in future. If you have the comments written there, then it becomes easy to understand what you have written, and also it is easy for someone else if they are looking at their code, at your code, and if you have like comments mentioned there, then they will easily get to know like in what the code is and what each line in a code means. So for example, here we have this code, and this row has its comment here, which is represented by semicolon. So as you can see, it says prepare to search in the lower half, which is your comment, and you know that this is your label, as it is mentioned here. This is your label, and this is your mnemonic, and this is your operand field, and this is your comment. So let's quickly read here. A comment starts with a semicolon. All characters to the right of the semicolon are ignored by the assembler. So if you start writing anything after the semicolon, then it is not going to be included in your code. It will just act as a comment. So comment provide documentation to the instruction or assembler directives. A comment may explain the function of a single statement or a function of a group of instructions. So so you understand that this is label, mnemonic, operand field, and whatever you have after the semicolon is your comment. Now let's do a quick quiz. So we have this this program statement, one line code, and we have to determine what are these different represents. So all these 4 fields we have to determine what these indicates. So by now you might be able to get this, that this is going to be your label, this is going to be your instruction mnemonics, this is going to be your operand, and this is going to be your comment because it is mentioned after semicolon. So that's your answer is label 2_low and add LW is your instruction mnemonic, and this is your operand, and this is your comment. So this is the end of the lecture, and in the next lecture we are going to start with the assembly directives. So thank you so much for watching this lecture.